Discover the cutting-edge world of offshore wind turbine installation, where innovation, precision, and powerful technology harness the energy of the sea. Heavy-duty round slings Magnum-X by SpanSet are used for lifting single monopile foundations during wind turbine construction. Each thick-walled steel monopile, produced by ZEB, can reach 6 meters in diameter and weigh up to 700 tons. Transporting and lifting these massive structures from the production site to installation requires exceptional logistics and professional lifting equipment. The Magnum-X slings are designed to endure extreme loads and harsh conditions throughout manufacturing, transport, and installation. SpanSet developed them to extend service life, allow inspection and repair, and provide 24-hour support tailored to the demanding schedules of the wind energy industry. Axion, a member of the SpanSet Group, is a specialized company dedicated to designing and manufacturing customized load handling and lifting equipment for the global wind energy industry. With years of experience in technical innovation, Axion focuses particularly on offshore projects, where the handling of extremely large and heavy components must meet strict safety standards and operate under harsh marine conditions. The company's solutions are recognized for their reliability, ease of operation, and high level of safety, making them indispensable for modern wind turbine installation and maintenance. Axion's wide product portfolio includes purpose-built systems such as monopile lifting tools, rotor tilting traverses for complete rotor stars, and the tower toolkit used in tower erection. Each product is carefully developed to ensure maximum safety and efficiency during complex lifting operations. The Axion Tower Toolkit combines all essential elements needed for lifting and assembling steel wind towers, such as the pulley, Vario J-hook, Magnum-X high-strength round sling, and the Vario tap adapter with a patented inner shell that allows a smooth and protective turning process. All components are perfectly matched, rigorously tested, and certified to international standards. Every system component of the tower toolkit is developed and manufactured by the SpanSet Group, guaranteeing full compatibility and quality. SpanSet Axion also provides detailed operating instructions and performs the necessary calculations for each specific project. This approach gives customers a fully integrated lifting system in which all parts are optimized for the task, eliminating the need to source items from multiple suppliers. Furthermore, SpanSet Axion assumes the liability for the entire delivered system, giving customers additional confidence and peace of mind. A remarkable innovation by the company is the Axion Rotor Tilting Traverse, specially designed for offshore installations on jackup vessels. This powerful device allows safe mounting and dismounting of complete rotor stars consisting of a hub and 3 pre-mounted blades directly at sea. Using built-in hydraulic cylinders and integrated electrical and hydraulic units, the traverse can rotate a rotor weighing nearly 150,000 kilograms by 90 degrees in just 10 minutes. Operation is controlled remotely by radio for maximum safety and precision. Certification and load testing were successfully carried out under the supervision of Germanischer Lloyd, ensuring full compliance with international offshore standards. The production of offshore wind turbine transition pieces begins with the fabrication of high-quality steel components, where dimensional accuracy is of utmost importance. Each element is precisely manufactured to ensure perfect alignment during assembly. In the next stage, the transition piece is assembled following strict engineering procedures. A multi-layer special coating system is then applied to provide long-term protection against corrosion in harsh marine environments. After coating, the platform is welded and equipped with railings, ladders, cables, and gratings to complete the structure. Every step is carefully monitored to meet offshore safety and performance standards. Thanks to efficient production management, the facility is capable of manufacturing up to 4 fully finished transition pieces each week. The installation of the Nexans E160 EP5 marks a new milestone in onshore wind energy technology. As the flagship of the EP5 platform, this turbine combines exceptional performance, robust engineering, and intelligent design to achieve maximum efficiency in low to medium wind conditions. With a rotor diameter of 160 meters and a nominal power output of up to 5.56 megawatts, the E160 EP5 E2 can generate more than 21,534 megawatt-hours of electricity annually at sites, with average wind speeds of 7.5 meters per second. The installation process begins with assembling the modular steel tower, available in several hub heights including 99, 120, 160, and 166 meters. Once the tower is in place, the innovative nacelle housing key components, such as the permanent magnet generator and inverter, is lifted and installed. This pre-assembled nacelle design minimizes installation time as it is fully cabled and factory tested. The massive rotor blades, each contributing to the turbine's 160-meter span, are then attached with precision lifting equipment to ensure aerodynamic balance and operational safety. The E160 EP5's direct drive system reduces mechanical complexity and maintenance requirements, providing a more reliable and cost-effective power solution. Designed for resilience, the turbine operates efficiently in extreme weather conditions from intense heat to freezing cold and withstands wind speeds up to 28 meters per second. Enercon advanced grid technology ensures seamless integration into local and international power networks, meeting stringent grid code standards. With flexible configuration options and multiple operating modes, the E160 EP5 can be tailored to diverse environments. Its LCOE-optimized design, combining performance, durability, and ease of installation, represents the next generation of sustainable wind power. In recognition of its groundbreaking engineering, the E160 EP5 was named Turbine of the Year in 2020 by Wind Power Monthly. The installation of the Gemini wind turbines involves precise offshore logistics and highly coordinated lifting operations. In Esbjerg, Denmark, the towers, nacelles, and 65-meter-long turbine blades are carefully loaded onto specialized installation vessels. Each voyage, the Aeolus carries 6 complete turbine sets, while the Pacific Osprey transports 8. The blades are stored securely in protective frames to prevent damage during transit. Once fully loaded, the vessels travel approximately 12 hours to the Gemini Wind Park, located in the North Sea. At the site, the vessel jacks up above the water, creating a stable platform for installation. Riggers prepare the transition piece to receive the turbine's upper components. Using advanced lifting tools, the crane carefully hoists and positions the nacelle, the housing that contains the generator, on top of the tower, 89 meters above sea level. Guided by riggers on the tower, the crane operator ensures precise alignment and secure fastening. Next, the three massive blades are detached from their transport frames and lifted individually, using specially designed tools for full control and safety. Once the rotor is complete, the turbine can operate efficiently and withstand wind forces up to level 11, automatically shutting down when necessary. By mid-2017, all 150 Gemini turbines were successfully installed and generating clean offshore wind energy. Martin Bencher transported 60 transition pieces, each weighing 300 tons, for the Arkona offshore wind farm from Denmark to Germany on behalf of Bladt Industries A/S. The company managed the ocean transport and project logistics, engineering and installing a special sea fastening system to secure the pieces in an upright position. A full QHSE package ensured compliance with offshore standards. The Arkona wind farm will supply renewable energy to about 400,000 homes annually. The Axion upending tool, known as the world's largest gripper, was developed for handling monopiles weighing up to 1/500 tons. Designed for offshore wind farms in deeper waters, it uses advanced control technology and adjustable functions to safely grip and upright even the largest monopiles with precision. The installation of the MAATS concentric carousel and bespoke deck lay system on the cable-laying vessel Nexans Aurora represents one of the most remarkable achievements in modern offshore engineering. Designed specifically for deep-water cable installation, this operation highlights both the technical precision and collaborative expertise required to equip one of the world's most advanced cable-laying vessels. The Nexans Aurora, measuring 149.9 meters in length, was built by Ulstein Verft AS and designed by Skibstechnisk in close partnership with Nexans. To optimize its deep-water operations, the vessel was fitted with a state-of-the-art concentric carousel developed by MAATS Tech. This carousel has an impressive cable storage capacity of 10,000 tons, enabling the vessel to handle long, heavy subsea power cables essential for offshore wind farms and interconnector projects. The installation process, captured in the time-lapse video, begins with the preparation of the vessel's deck at Ulstein's shipyard. The large steel carousel structure, consisting of multiple concentric rings, was fabricated and transported to the shipyard for integration. Precision lifting operations were carried out using heavy lift cranes to position the carousel components accurately on the prepared foundation. Once the base structure was secured, the central hub and rotating mechanisms were installed. These components allow the carousel to smoothly store and deploy subsea cables with minimal tension, ensuring operational safety and reliability even under harsh offshore conditions. Engineers then fitted the supporting rollers, power units, and control systems, followed by alignment and testing procedures to confirm smooth operation. In parallel, the MAATS bespoke deck lay system was mounted and connected to the carousel. This system includes cable tensioners, loading arms, and guiding equipment that ensure the controlled handling of cables from the carousel to the vessel's stern during laying operations. Every stage of the assembly was conducted under strict safety and quality standards, reflecting MAATS' extensive experience in offshore cable handling systems. After the mechanical installation was completed, the entire system underwent functional and load testing. The carousel was rotated and tested with dummy cables to verify its capacity, control response, and synchronization with the deck lay system. Once all systems were validated, the Nexans Aurora was ready for commissioning and subsequent deployment in deepwater projects worldwide. The successful integration of the 10,000-ton MAATS carousel on the Nexans Aurora demonstrates exceptional engineering coordination between MAATS, Nexans, Skibsteknisk, and Ulstein Verft AS. It marks a significant milestone in the development of high-capacity cable-laying vessels, enhancing efficiency and capability for the growing global offshore renewable energy industry. Boskalis successfully completed the installation and burial of 98 inter-array cables for NBW's QHSE and Albatross offshore wind farms located in the German North Sea. This large-scale project connected the offshore wind turbines to the substations, ensuring efficient power transmission to the grid. To accomplish this, Boskalis deployed a wide range of in-house assets, providing a fully integrated solution. 3 specialized cable-laying vessels were used to transport, lay, and position the cables on the seabed with high precision. A walk-to-work vessel ensured safe and continuous crew transfer between vessels and offshore structures, enabling uninterrupted operations even in challenging sea conditions. For cable burial, the ROV Trencher 700 to 1100 was employed to safely embed the cables into the seabed, offering protection against external damage and environmental impact. The combination of advanced equipment, expert project management, and extensive offshore experience allowed Boskalis to execute the work efficiently and within schedule. The completion of this project marked a significant milestone in supporting the sustainable energy goals of Germany, as QHSE and Albatross together generate over 600 megawatts of clean electricity, powering hundreds of thousands of homes. This installation demonstrated Boskalis' capability to deliver complex offshore cable projects from start to finish. The Endurance is a state-of-the-art offshore cable-laying vessel owned and operated by Boskalis. Built in 2013 and sailing under the flag of Cyprus, the vessel is specifically designed for the installation of subsea power cables used in offshore wind farms and energy interconnections. With a length of 99 meters, a beam of 30 meters, and a displacement of over 12,000 tons, The Endurance offers a powerful and stable working platform for complex marine operations. Equipped with Dynamic Positioning Class 2, the vessel can maintain its exact position even under harsh offshore conditions. Its large turntable system, capable of carrying up to 300 tons of cable, enables efficient and continuous cable laying operations. The deck layout includes advanced tensioners, cable engines, and remotely operated vehicle systems for precise monitoring and burial of cables. Besides cable laying, the Endurance is a multi-purpose vessel that can perform rock placement, diving support, and subsea construction work. It is powered by a 500 kilowatts propulsion system that ensures excellent maneuverability and energy efficiency. In July and August 2020, the Endurance was filmed departing from Dordrecht, the Netherlands, for an offshore project, demonstrating Boskalis' advanced capabilities in the renewable energy sector. Combining technology, versatility, and reliability, the Endurance plays a vital role in connecting offshore wind farms to onshore grids and supporting the transition to sustainable energy worldwide. Hywind Scotland marks a historic milestone in renewable energy as the world's first floating offshore wind farm. Developed by Equinor, the project builds upon the success of the Hywind demo, a full-scale prototype installed off the Norwegian coast. Initially met with skepticism, the demonstration unit proved remarkably successful, exceeding production expectations and providing crucial data for future development of floating wind technology. Located off the coast of Peterhead, Scotland, the Hywind Scotland wind farm consists of 5 Siemens 6 megawatts turbines capable of supplying clean electricity to around 20,000 UK homes. What makes this project revolutionary is its floating design. Unlike bottom-fixed turbines, each Hywind turbine stands on a floating substructure, an enormous steel cylinder over 90 meters long, 14.4 meters in diameter, and weighing approximately 500 tons. These substructures were built by Navantia in Spain, while the 20-meter tower sections were manufactured by Navisil. The turbines are anchored to the seabed with 3 mooring lines attached to massive suction anchors, each 5 meters wide, 16 meters tall, and weighing 111 tons, produced at Nig Energy Park by Global Energy Group. To maintain stability, each floating unit is ballasted with 5,000 tons of iron ore. The system is equipped with a motion controller that continuously adjusts the turbine blades to minimize movement and optimize power generation even in rough sea conditions. Assembly took place at Stord, Norway, where the towers, nacelles, and blades were carefully mated onto the floating structures, an extremely complex heavy lift operation. Once assembled, the turbines were towed across the North Sea to their final location and connected into a single power grid. Commissioned in 2017, Hywind Scotland proved that floating wind technology is both feasible and efficient, opening new opportunities for harnessing wind energy in deeper, windier waters around the world. The construction of the Gemini Wind Park, one of the largest offshore wind projects in the world, began with the development of the land high-voltage station in Eemshaven, the Netherlands. This onshore facility serves as the central hub for collecting, converting, and transmitting the electricity produced by the offshore wind turbines to the national grid. Its construction was a vital step in ensuring the stable and efficient delivery of renewable energy to thousands of households. The first major stage of the project was laying 210 kilometers of export cable, which connects the offshore substations to the Eemshaven HVS. These cables were installed with great precision and then buried underground and under the seabed to guarantee durability and protection from external impacts such as anchors and fishing activity. Meanwhile, the fabrication and transport of 150 monopiles, the steel foundations that anchor the turbines to the seabed, were underway. Each monopile was designed and manufactured to withstand harsh marine conditions and heavy turbine loads. In parallel, 150 transition pieces were fabricated and transported. These components connect the monopiles to the turbine towers and provide access platforms and cable entries. Once transported to the offshore site, installation teams successfully completed 150 foundations in just 110 days, an impressive achievement that required precise coordination and favorable weather conditions. Following this, the offshore high-voltage station jackets and topsides were transported and installed, forming the offshore electrical network that gathers the power generated by the turbines. Afterward, 150 infield cables were laid to connect all turbines to the substations, and a trencher buried them into the seabed for protection. Finally, the heavy-lift vessels Aeolus and Pacific Osprey installed all 150 wind turbines with remarkable accuracy. Upon completion, the Gemini Wind Park became capable of supplying renewable electricity to 800,000 households, marking a significant step forward in Europe's transition to sustainable offshore wind energy. The Axion Rotor tilting traverse is a state-of-the-art lifting system specially engineered for the offshore wind energy sector. It is designed to handle one of the most complex and critical operations at sea, the assembly and disassembly of complete rotor stars, which consist of the central hub with 3 pre-mounted blades. These rotor stars are among the heaviest and most delicate components of a wind turbine, and handling them safely in offshore conditions requires precision, strength, and advanced control technology. Developed for use on jack-up erection vessels, the Axion system features a hydraulically driven tilting crossbeam that allows the rotor star to be turned a full 90 degrees in mid-air, even when the blades are attached. The equipment is capable of handling a rotor weighing up to 150,000 kilograms, and remarkably, the tilting process takes only about 10 minutes. This outstanding performance is made possible by hydraulic cylinders permanently installed in the crossbeam, combined with electric and hydraulic units integrated into the traverse. Operation and control are performed wirelessly via radio, ensuring maximum operator safety and flexibility during offshore operations. The assembly sequence follows a series of carefully coordinated steps. First, the pre-assembled rotor star is lifted horizontally from the deck of the jack-up vessel. Once clear of the support frame, it is slowly raised and gently rotated into a vertical position using the tilting mechanism. In this position, the rotor star is precisely aligned and mounted onto the nacelle of the wind turbine tower. The process requires extreme precision as it takes place hundreds of feet above sea level. For disassembly, the sequence is reversed. The rotor star is detached from the nacelle, slowly tilted back into a horizontal orientation, and finally set down safely on the vessel's deck as one complete unit. A notable innovation of the Axion design is its patented inner shell, which ensures a smooth and gentle tilting process, minimizing stress and torsion on the blades and hub during handling. This feature is particularly valuable when working under changing wind conditions at sea. The system's robust construction and precise hydraulic control guarantee stable operation even in challenging marine environments. Een voordeel bakolevo. All components of the rotor tilting traverse are built to meet the highest safety and quality standards. Certification and acceptance tests were carried out by Germanischer Lloyd, one of the most respected certification authorities in the maritime and offshore industries. The complete load test was successfully performed on the Axion testing stand under their supervision, confirming the equipment's reliability and strength. In summary, the Axion rotor tilting traverse represents a technological milestone in offshore wind turbine installation. By combining hydraulic power, intelligent design, and certified safety, it enables fast, accurate, and secure handling of complete rotor stars at sea, contributing to the efficiency and safety of offshore wind farm construction and maintenance operations.